What is going on, guys? Vlad here with SolisPLC.com, and with 2019 coming to a close, I just wanted to make a video sharing some of the devices that I've acquired recently, which you will be probably seeing in the next couple of videos, but essentially it also gives you an idea of what I'm working on, what you can buy for some of your own projects, and just in general give you some overview of some of these devices. So first on my list is going to be the Raspberry Pi 4 Model B with 4 gigs of RAM. So in case you haven't seen my videos on inductive automation ignition, which is more specifically Ignition Edge, then you'll know that I'm actually trying to set up a device which is going to be able to host a whole bunch of different PLC tags and be able to supply an application onto my network so that I can continue to control my PLC over the network without the need of going into the program or using an HMI. So this is the first and a really cool device that I've purchased, and you're probably familiar with the Raspberry Pis, but like I said, if you're looking to buy one, these are really cheap. They run a Linux-based operating system, and they come with all the ports that you need. As you can see, there's some USB 3.0 ports. There's going to be an Ethernet port. One thing that I do have, I guess, a comment about is the fact that they've changed to the small or the micro version of the HDMI, as you can see here. And of course, the power is now over USB-C, which is okay, I guess, because I do have a phone that's powered through the same cable, so I will be using that. What you also saw in that box is a Raspberry Pi Zero. So this is the non-wireless version, which I've purchased a long time ago. I just never actually picked it up or unboxed it. So this is the same equivalent, so it's a Raspberry Pi Zero. It only comes with a half a gig of RAM, and it is missing quite a few of different peripherals. So that's going to be a little bit of an issue, I guess, or a problem, because you're still going to have a lot of dongles to be able to connect over Ethernet. So you're going to need a USB to Ethernet dongle, which makes it a little bit, I guess, unappealing, because the dongle usually costs $15 or $20. So it's going to come up to be almost the same price as I guess a stripped down version of this number 4. So those are the first two really cool devices that I'm going to be using for inductive automation's ignition. Next, we have a few Cognex cameras. So I have these barcode readers as well as the 7000 camera. So this was actually a gift from a friend of mine in California. So this is a really cool camera that I'm going to be using for my essentially my Cognex camera class, and I'm going to be creating a couple of different tutorials on this. But ultimately, what I hadn't realized immediately is that these cameras, both the barcode readers as well as this specific camera, they need PoE to operate. So in case you haven't watched my Cognex video, you do still have to use this 8-pin conductor cable for the Ethernet connection, so you can plug it in right here and of course screw it in. But this specific camera, unlike the other one that I had mentioned on the channel before, does require power over Ethernet. So in order to accommodate that, I actually purchased one of these Cisco switches on eBay. So it's a power over Ethernet 8-port switch, and I can give you the exact model number. That's going to be the SD208P. So this is another really cool device. It comes with its own adapter, and of course it sends 48 volts over the Ethernet cable, allowing me to power any of these cameras and connect to them like so. And some of the Rockwell switches do have that capability, but they are on the expensive side. This one only cost me, I believe, $40, so very inexpensive investment. And a lot of the devices are coming with that specific powering, I guess, capability, so it's important to have a PoE switch on hand. So that's for the Cognex stuff. Next, we have this really cool armor block. So in case you're not familiar with the armor blocks are essentially the equivalent of what you'd see on a point IO or the control net equivalent. And what they allow you to do is to drop this block onto your machine and then have a Ethernet connector coming in, and you can daisy chain them essentially, or you can even make a DLR or a device level ring. But you can set up multiple devices like so inside of your machine, and they allow you to connect your sensors into these ports. And based on the lights, you'll notice that there's going to be 2 sensors that you can connect per single plug. And ultimately, what's the advantage of this over point IO? So of course, it is going to come at a higher price point per input or per output, but what it's going to do is allow you to essentially place this very robust solution right in the field. So if you're working with Point.io, then you typically need a panel, you need something that's going to enclose that entire device and mount it on a DIN rail. But in this case, you can essentially screw this terminal in directly into your machine backplane, and you can essentially connect very, very closely to your sensors. And at the end of the day, what you're going to be doing is saving on the cost of wiring and installation. So ultimately, this allows you to have a single cable that runs from the main panel into this specific device. And sorry, I'll correct myself. So that's going to be 2 cables. So you're going to need 1 Ethernet cable and you're going to need 1 power cable. And of course, you can daisy chain those as well. But ultimately, you're going to have to disconnect 2 of those cables and you can remove your machine from the field. Versus Point.io, you're going to have your Point.io module inside of a panel, and then you're going to have multiple wires running from your panel into the machine. So it makes it a little bit different of a wiring scheme, but in certain situations, it's better to use these modules. Another place that I've seen this used is when you have a rotary device. So when you have only a limited number of wires available on a device that's, constantly rotating. Obviously, it's not going to be the armor block that's going to be rotating, but a large device that rotates, then you send the Ethernet and the power only over those limited number of connections. And then you have many devices on that rotating device that are connected to the field sensors or field heaters, for example, which you can also obviously power through the power over here. And you can activate and deactivate through the outputs on the armor blocks. So if you're wondering what's the device part number, it's going to be right here. So that's going to be 1732E, and I'm going to post this on your screen. But it's 1732E 16CF GM12QCWR. And we're going to be looking at this block in some of the next videos. So thank you guys for watching. Let me know if you enjoyed this type of content, if you want to see some of the devices that I have. And I will see you next time, where we're going to be looking at some of the other PLC programming, HMI development, and camera programming. Thank you guys so much for watching my content. If you have any questions on this topic, make sure to leave them in the comment section below. And if you can spend 5 seconds of your time liking as well as sharing that video if you've enjoyed it, that would mean absolutely the world to me. And if you have any suggestions for the channel, what kind of hardware, software I should be covering, then make sure to leave that down there as well. See you next time. Take care. Bye.